Welcome to Database Development Lecture 28, Data Warehousing, OLAP, Data Mining, and from OLAP to data mining. Previously, we analyzed what is OLAP, which is online analytic processing. So, what is the corresponding concept is OLTP, which is online transaction processing. For this lecture, we're going to talk about data mining, which can be as an extended form of OLAP. So, find the factors that have the most influence over sell the product as, rather than trying out the queries like from the sales, from select models on price, from sales natural drawing products with type equals X group by model. So the data mining refers to the discovery of finding the known patterns and knowledge of the data, and nearly 50% of the people who try to buy the hot dog must buy the mustard, because these two things are eat together, and these individual patterns of the bank transaction indicate that they're running a terrorist cell. So we can combine many areas of computer science and mathematics, just like machine learning and the statistics and data management. Here we are going to illustrate some of the basic methods. So the data mining, the real life example is just like for the supermarkets, they can manage to send the promotion sales of the diaper before some of the families has announced that they are pregnant. So and maybe the Gmail can use the stamp detection method to get some feature timed with the read to know whether it is stamp or not. So there's some ethical concepts that whether they can use the purchasing records to see whether they are pregnant or not. There are some ethical issues, but we do not talk about them here. And the scenario one is like the market checkout. So imagine there's a market, and we are going to see the purchase ID, item bought, and we actually illustrated in this paper. So this is used for decision making, which items are frequently bought together and can influence the item placement, decision on the price, and so forth. Can we identify some relationships, just like diapeters and peers? The diapeters in Chinese they call it 纸尿布 and so we may also see like the streaming service, like there's some here are some films, and here is the all customers for them, and here are some possible questions that which viewers frequently like the same film, and we can be used for the recommended film. And data can be described as a set of the item I and a set of the basket B. For each basket B, there is a suitable I. And for example, in this case, it's a purchase ID Z and the item put together. This 1, 2, 3, 4 buckets, and this is item. And so in this case, the bucket have index of 1 to 4, and the item are all the things that are taking place here. So the mathematical representation for this one, these two are equivalent. And so another example is that in this case, these are the items, and these are the baskets, and the frequent item mining. So which items are frequently bought together? So firstly, we are going to introduce a concept of the support, which means that the support of subset G of I is equal to the frequency of which the items in G occurs together with the basket in B, which is just equal to the number of buckets in B containing all items in G divided by the number of buckets in B. So for example, what if we want to find the support of milk and juice? We just want to find all the milk and juice. Okay, milk and juice once, milk juice twice, and there is milk juice in the following. So the support of milk and juice is 2 divided by 4, is 0.5. And what if we want to find the support of bread and juice? We just find everything bread. So this is bread, and this is juice, this is 1. And no bread but juice, no juice but bread, and bread but no juice. So this is 1 divided by 4. So this is the support or something, and the frequent item here is that we're given a set of item I and a set of bucket B. So we are going to set a threshold for the support. For example, let's say the threshold is 0.5, and what if the support is greater or equal to 0.5, then they are frequent. And what if they are less than, then it is not frequent. So let's say milk and juice are frequent, and the bread and juice are not frequent. And the x here is let's see, what if we can find the bi and bs? So in this case, it's bi and bs is just like this one, and this one, and all others are not how bi and bs occurring together. So it's 4 divided by 8. It's 1 divided by 2. So it is frequent since 4 divided by 8 is greater than 3 divided by 8. And we can also find other frequently divided atoms such as Harry Potter 1 and Harry Potter 2. And so this is this. Thank you for comment and subscription.